The proportional segments theorem is very similar to the triangle proportionality theorem or the side splitter theorem that we just talked about. Essentially, though, instead of making the triangle, completing the triangle, we're saying that if three parallel lines intersect two transversals, then they divide the transversals proportionately. So in this case, we have L1, L2, and L3. They're all parallel. So we are going to have that A over B equals X over Y, or A over X equals B over Y. The way I like to see it best, okay, that makes sense to me, we've got that, we've got that, we've got that right there. Okay, so A over X equals B over Y. To me, that makes the most sense. That middle transversal kind of splits it up for me. So let's utilize some of that information to help us solve these questions. 4 over 6 equals 6 over X. Like I said, it's just that easy to write our proportion. And then once we do, we cross multiply. 4x equals 6 times 6, which means 4x equals 36. And then we can divide both sides by 4. 36 divided by 4 equals 9. Okay. Over here, very similar. It's a little bit different, but we can set my equation right here. So x over 10 equals 6 over 8. Cross multiply. Once we get that equation written, it's a very simple process. 8x equals 6 times 10. 8x equals 60. Divide both sides by 8. And x equals 60 divided by 8, 7.5. Again, let's go on ahead and set our equation. 4.4 over 6.3 equals 1408 over x. And we're going to cross multiply and divide yet again. 4.4x equals 6.3 times 14.08. We will multiply that out. So 4.4x equals 6.3 times 14.08. We get 88.704. And then once we get that, we can divide both sides by 4.4. X equals 88.704 divided by 4.4. So we have 20.16.